Okay, it's time for, I think, our seventh one already. This is G. Okay, here we go. Because they're so long to write these problems, that's the problem. All right, so we'll get our heading again. Math 108, Spring 21, Exam 3, Review. And this is already, we're up to G, I believe. Okay, so we need to do problem number 13, which entails a little bit of writing. A service offers catering service offers 8 appetizers. All right, 8 apps. 10 main dishes, 4 desserts, okay. Now, customer selects customer selects 3 appetizers, 8 mains, and 2 desserts. Okay, so how many ways can this be done? How many ways can this be done? How many ways, any ways can this be done? That is the question. How many ways can this be done? That is the question. All right, so the answer is we don't care what order these things come in. Here comes the answer. So we know order is not important, isn't important, right? Order isn't important. Right? How the appetizers come in one after that's not important. So it's going to be a combination. So now, what are the total amount of appetizers? So it's a combination. The total amount of appetizers are 8, and the customer, selecting 3. What's the total amount of main dishes? It's 10, and the customer is selecting 8. What's the total amount of desserts? 4, and the customer is selecting 2. And the order is not important. It's just a question of how many ways this can happen. So of course the appetizers combined with all the possible ways of the mains and with all the possible ways of the desserts. So there's a multiplication principle going on in between, and that is essentially the answer. So doing a little bit of the scrap paper work with you here, you can actually figure this out yourselves, but this would be 8 factorial over 3 factorial 5 and 8 minus 3, which is 5 factorial. That would turn into 8 times 7 times 6, right? You combine it with you take the largest one, over 3 times 2, right? You would take these two together, over 3 times 2. 3 times 2, that is 6. So what do you get from out of that? You get 56. All right, that's one piece of scrap paper. The next one with the 10 and the 8 would be 10 factorial. 10 factorial over 8 factorial. And 10 minus 8 is 2 factorial. So you would do the 10 and the 8. You would combine them. What would they equal to? That would be 10 times 9. 8, stop. Don't take it. Divided by 2. The 2 goes into 10 5 times. You would get 45. A little bit more scrap paper. Let's push this up. We would have the last one would be the 4 and 2 one. So it would be 4 factorial over 2 factorial, and 4 minus 2 is 2 factorial. There's a tie, so take any one you want. This would turn into 4 times 3 over 2. 2 goes into 4 twice. 2 times 3 is 6. We have 6. This means this is 56 we figured out, times this is 40, this one is 45 we figured out, times this one is 6 we figured out. What does that equal in the end? Use your calculator and you have the final answer. That's problem number 13. Okay, we need to go on to problem number 14. We need a new piece of paper most of the time with these. Actually, we don't. This is maybe the one time that we don't need a new piece of paper because 14 is short enough. Let me show you 14. So 14 is short for a change. Here we go. You get weights, bunch of weights data. You get weight data. Of what? Of whatever, an animal, maybe whatever it is. Weight data. What are the? Here's the raw data, and it's not organized in any way. Raw data: 24, 3. Let's say it's pounds. 24 pounds, 3 pounds, 29 pounds, 24 pounds, 8 pounds, 38 pounds, 62 pounds. Question: what is the range? Okay. Scan the data for the highest one, 62. Then scan the data again for the lowest one. You don't have to arrange it. You can just scan. The lowest one is 3. Highest 62, lowest one. 62 minus 3 is equal to 59. And that is the range. That is the range. Pretty straightforward question or problem. Okay, so now which problem was that? That problem was 14, which I forgot to put right over here next to it. We can go on to 15 with a new piece of paper. Here we go. We don't need this. We need to get a new piece of paper and go on to problem number 15 as follows. 15. All right, what if you have hours worked? I'm going to give a table of hours worked by 16 people. Hours worked, and this is a total of 16 people involved here. You might not necessarily be told that it's 16 people, but let's say you are. Okay, so they give us a stem and leaf plot. And I have to explain that because we didn't talk about that. It's not going to be complicated at all. Display or plot? Plot or display? Okay. Here's how they organize it for us, and we'll explain in a second. On the left-hand side, there's a 2, and then next door there's a 5, and a 5, and a 9. Those are separate numbers. Then comes a 3, and then there's a 3, and a 4, and a 5, and a 7. Then there's a 4, and there's next to that is a 0, and a 2, a 5, an 8, and a 9. And finally there's a 5. Next door is a 1, a 7, a 9, and a 9. And then it says the key, which is a little cryptic, but I got to give me a chance to explain. The key is 2/5 means 25 days, right? So hours, 25 hours I meant. 25 hours. It's all about hours worked. Okay, this is how you read this. The 16 people are represented over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This first one says that there was somebody did 25 hours, another person did 25 hours, another did 29. That's what this key says, 25 hours. The third person on this list did 35 hours, the fourth did 37. This one, someone did 40, someone did 42, someone did 49, someone did 57, someone did 59. That is how this key works. It's not so complicated. Here's the questions they ask. A, highest in the 40s. Who did the most hours, but in the 40s hour category? The answer, here's the answer. Look at the top one was 49. That's the answer. Highest in the 40s is 49. Okay, question B. Pretty reasonable questions, pretty easy to follow. Least number of hours worked. Who did the least of all? Least hours of all. Okay, well, in 50 you did a lot, 40 you did a lot, 30 you did a lot, but 20 you did not. The answer is that not who, but the least hours worked by anybody, and there's a tie, is 25 hours. 2 people did 25 hours. They did the least. And number C is how many in the 30s? How many people, how many in 30s, meaning that did 30 in the 30s hours of work? Well, 1, 2, 3, 4. Someone did 33, someone did 34, 35, and 37. There's 4 people. So the answer to that question is there's 4 people in the 30s. And that's pretty straightforward question. That's all there is to it. And we can move on to problem 16. Okay, here we go. All right, so now problem number 16. I still want this higher. Yeah. Okay, problem number 16. And if we're just in case we need that space. All right, so 16A. What are the odds in advancing 5 spaces in some board game? Here in advancing 5 spaces. So here they give us the odds. They give us the odds. And again, I remarked this last time in the last test that sometimes they'll give us odds like this. We're used to 3 to 8 or 3:8, but they might give it to you as a fraction. So this is for in our language, this would be 3 to 8. Okay, they give us the odds, right? We use in parentheses, we use in class we use, and so do they also do it sometimes. All right, but anyway, this would mean the same thing as 3 to 8 or 3 to 8. Okay, parentheses. Fine. Those are the odds. Here's the question. The question is, what's the probability of moving 5 spaces? Of advancing 5 spaces? Okay, the answer is, these are the odds. So those are all the chances. So how many chances in all? 3 plus 8, which is 11. That's our denominator. And what's this? Odds of advancing 5 spaces is 3 to 8. So we're interested in advancing 5 spaces as well. So our answer is 3 over 11. Because the 3 represents advancing. Okay. B, we have a little bit more time here. B, you have the probability of choosing cherry candy is equal to 7 over 22. Okay, what are the odds against it? Choosing a cherry candy. What are the odds against? Here comes the answer. The answer is 22 minus 7 is the odds against, the chances against it. So it's 15 to 7, otherwise known as 15 to 7. 7 or 4, but 22 minus 7 is against, so this is the answer for the odds. Okay, let's stop here, end this video. Here we go.